Question 17, factorise 4m plus 12. You can actually get two answers for this because it doesn't say factorise fully. So 4 and 12, what have they got in common? Well, they've both got a 4 in common. And if I divide both of them by the 4, I'm left with m plus 3. What you could have also done for this one is recognise that 2 is a factor of both of them. They have a 2 in common. So put 2 on the outside of the brackets, divide both sides by 2, I'm with 2m plus 6. Both answers are absolutely fine there. Okay, 5y is a term, because there's only one part to it, it is a term in the something 3x plus 5y. Well, if it was an equation, it would have an equal sign, and it would probably only have one, if it was a linear equation, it would only have one unknown. Formula would have an equal sign. Identity would also have an equal sign. Inequality would have the inequality signs. We've already found a term. A factor would mean that 5y, I can times 5y by something to give me that. And multiple is if I were to multiply that. So it is actually expression. Question 18. Here is a sequence of patterns made with counters. Find an expression in terms of n. Well, firstly, I'm going to count how many counters are in each one. So there's 1, 3, 4 in pattern 1. There's 1, 2, 4, 5, 6, 7 in pattern 2. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in pattern 3. So, with that in mind, I need to find the nth term of 4, 7, 10. Well, it's going up in, the difference between them is going up in 3s, so I know it must start with 3n. The jumps between there and there are add 3. Now, I've got the first part to my nth term. I now need to write out this times table, the 3 times table. So 3, 6, 9, and need to work out my corrections. How do I get from 3 to 4, from 6 to 7, or from 9 to 10? I add 1. My nth term is 3n, add 1. Bayo has 90 counters. Can Bayo make a pattern in the sequence using all 90 of his counters? So what we want to know there is, can we ever get a time when 3n plus 1 equals 90? I would solve this like an equation. You guys are more than welcome to draw it out and work out the numbers, that's fine. But I'm going to build a wall and I'm going to take away 1 from both sides. Okay, so I'm left with 3n equals 89. Okay, so now to get n on its own, I need to divide by 3. So 89 divided by 3 is... is 29.6 recurring. So, because that isn't a whole number, an integer, we cannot say that 90 is a term in that sequence. So no. No. Because 3 is not a factor of 89. There are other ways that you could answer that question. You don't have to follow that same method.